Hello, myself Sudhir Pawar, and here I'll teach a topic called friction. Friction is a topic of a chapter called Newton's Law of Motion, which is in the physics subject of 11th standard. So let's start to introduce the topic friction. So, what is friction? So, friction is nothing but a force which exerts between two contact surfaces. When there is a relative motion or have tendency of relative motion between those two contact surfaces. Here some there are some conditions like friction will be acting only if surfaces are rough and those two rough surfaces should be in contact. And here I used one more term, relative motion. Relative motion is nothing but the motion of one surface with respect to another. See, every object has a surface. When this object is placed on the ground, when this object is in contact with this ground, so the surface of this object, this one, the bottom surface, is in contact with this ground surface. So these two are our contact surfaces. Now the friction is a contact force which will be acting on the contact surfaces. So friction will be acting on this surface and on this surface. Okay, so this is the friction. So in short, friction is the force which exerts between two contact surfaces, given that surfaces must be rough, when there is a relative motion between contact surfaces or have tendency of relative motion between those two surfaces. So this is friction. Now, how does it act? So direction of friction. So let's say there are two surfaces, contact surfaces. Now I'm applying an external force here in this direction. So this is an external force. Now this force is trying to push this block in right hand inside direction. So now if we see these two contact surfaces, surface of this object, this one, and the surface of the ground. These two surfaces are called contact surfaces because these two surfaces are in contact with each other. So now when we apply the force on this object will have tendency to move forward. So along with this object, the surface of this object will also move. So now this surface has tendency to move forward. But the surface of the ground is at rest. So we say that with respect to ground, the surface of the object is moving forward. Means there is a relative motion. Relative motion is a motion where motion of an object is moving. Object is moving with respect to another object. That is called relative motion. So here the surface of this object is moving forward. It is moving with respect to this surface of the ground. Okay, there are two possibilities. The surface is moving and the surface has tendency to move. So like I said, friction, when does it act? It acts when there is a relative motion and have tendency of relative motion. So here, so let's say, so when we are applying a force on this object, so here this surface has tendency to move forward. The two possibilities are there. This surface can move or it cannot move. It depends on this external force. How much force you are exerting or you are applying on this object. Let's say we are applying a small force. for instance, and we are assuming that the surface of the block is not moving, but it has tendency to move forward. So here friction will be active. Now, in which direction friction will act? So let's say, so first of all, the main purpose of friction is to stop the relative motion between the contact surfaces. There is a tagline of the friction. So one thing this time we have to remember that what is the job of friction is to stop the relative motion between the contact surfaces. So here, this surface of the object is trying to move forward and the surface of the ground is not moving. So with respect to this surface of ground, this surface of the object is moving forward. So it has tendency now. So what the friction will do? Friction will try to stop the relative motion. How can it stop? One way is to apply a force on the surface of object in left hand side direction. Because it's moving forward, so friction will try to pull it back. It don't go, come back like that. So on the surface of the object, friction will be acting on left hand side. And second way is that friction will act force on the surface of ground in forward direction. So that these two surfaces always remains at rest with respect to each other. That is the job of friction. To neglect to remove the relative motion between the contact surfaces. So these are the directions of frictions on both surfaces. So on the surface of object, friction will be acting leftward, and on the surface of the ground, friction will be acting forward. So that's how the friction will be acting. Let's same thing, like for example, if you're applying force in this direction, now the surface of the object is moving in this direction, or it has tendency to move left hand side direction. So friction will try to stop this surface. So friction will be acting in this direction on the surface of the object, or friction will be acting on the surface of ground in left hand side direction. So that's how the friction acts on the contact surfaces. Direction of friction is always along the contact surfaces. That's the important thing to remember. Always. So what you have to see is to find out the contact surfaces. Once you find the contact surface, then you see in which direction the relative motion is occurring, in which direction relative motion is happening. And based on that, you apply the direction of friction. What you have to do is to study the individual surfaces. Otherwise, there are chances to make mistake. So here we have contact surfaces, one surface of the object and one surface of the ground. So what I noticed here that we are applying force on this one. So surface of the object is moving left hand side direction, and the job of friction is to stop the relative motion. How can we stop the relative motion? We'll apply the force on the surface of the object in right hand side direction. When it's moving forward, it's moving in this direction. So friction does not want that there is a relative motion. So that's why the friction will act in right hand side direction, and at the same time on the surface of ground, friction will be acting left hand side direction. So here we can say that one more property of friction is the friction follows the Newton's third law. It is a kind of action reaction force, which is in same in magnitude and opposite in direction. Okay, so that's how the friction will be acting. So this is about direction. Let's move forward. Surface. Talk about the surface. Like every time when I was saying about the friction, I was using a word surface. In physics, there are two types of surfaces. One is smooth and second is rough. A smooth surface, if we talk about, so there is no friction. We don't need to think about the friction. Because surface is smooth. I'll tell you why. And second, rough surface. Friction acts always on rough surfaces. Now, study about the rough surfaces in detail. Normally, we draw the surface like this. But this is the object, this is the surface, this is surface of ground, like that. But now, when we see the surface at microscopic level, electron microscopic level, so what we'll find out is the surface is not longer smooth, plain. It has some zigzag shapes. If it is rough, and in our in this world, every surface is rough. Smooth surface is just a hypothesis. All surfaces are rough. So which means friction is everywhere. Okay. So this surface is like this. Now what happens? So both surfaces are rough. Both surfaces are like this. So this is the surface of block. Of block. And this is the surface of ground. So what happens when you place this object on the surface on the ground? These two surfaces make bonds. They get interlocked. Like if draw here is like this. One surface is like this, second surface is like this. So when you place like this, what happens? They will make interlocks. Like let's show like so. But this is the surface of one block, and this is surface of another block. So we'll make the interlock. Now it happens in rough surfaces. Now, in order to move the block, what we have to do? We have to break these interlocks. Then only the block will move forward. On the smooth surface, these interlocks are not there. That's the difference between smooth surface and rough surface. So what happens in a smooth surface? We don't need external force to move this block. But in rough surfaces, we need because we have to break these interlocks. So what happens here? We have to like we want to move the block, so we have to apply the force. Now that value of that external force depends on the strength of these interlocks. The stronger these interlocks are, the value of the external force should be. So if it is large, the value of external force should be large. That's why we have to apply a large force to move that block. It will not happen at small force. So when you apply the large force, what happens? Sorry. What happens is at very large force, what happens? These interlocks breaks. Listen, these interlocks will not break at a small force. Like there's smooth surface. Let's say, for example, we need a 1 Newton force to move it. But when interlocks are there, so obviously we don't need 1 Newton force. We have to apply force greater than 1 Newton. So that extra force which we are applying to move this block, that extra force is nothing but the friction value. Because now see, when we are applying extra force on the block, and this extra force keeps on increasing to break these interlocks. Let's say at 10 Newton, the interlocks breaks. Now again, the block will move forward and again interlocks will be there. So in order to move that block continuously, we have to apply force 10 Newton continuously. So who is stopping this block to move? And answer is friction. This is just way to explain like why do we need extra force to move. When in reality, friction is present. And because of friction, we have to apply an extra force to move it, this block. Okay, so these is about the surface, rough surface. Now we'll talk about the friction. Now the friction value. Sorry. Now if we talk about the friction value, so friction value on what factors does it depend? So first of all, depends on the strength of interlocks. How strong it is. Like if it is like this, so small force will break this. Like if it is like this, larger force we have to apply. So depends on the strength of interlocks. And the strength of interlocks depends on the force exerted by the block on this surface, which is called normal. There's a normal. This is another kind of force. This is also action reaction force. The block is placed on the ground. So we'll say here the block is applying force on the ground in downward direction, and the ground is applying force on block in upward direction. Those are normal forces, which is also explained by the Newton's third law, action reaction. So it also follows the action reaction. So here ultimately the friction value depends on the norm. So how it is depend? So there is a relation. The friction is directly proportional to norm. And when the proportionality is removed, we bring a constant which is nothing but coefficient of friction f equal to mu into n. So this is the friction value which is equal to mu into n, where mu stands for the coefficient of friction. Now here there are two types of friction. One is static friction and second is kinetic friction. Now at the beginning I told that when we apply force on the block, so there are two possibilities. The block will move or it has tendency to move. When block has tendency to move, which means it is not moving, but it is going to move next couple of seconds and couple of time later. In that case, we are applying force, but still block is not moving, which means a friction is active. Because acceleration is zero. Or acceleration, when does it happen? When net force is zero. So here we say when we are applying F force on this direction and block is not moving, which means this F force is balanced by another force, and that another force is nothing but friction. And this friction, when the block is not moving, when relative motion is not happening, is called static friction. And when it is moving under external force, that is called kinetic friction. See, friction will be acting only in presence of external force. This F. In presence of this only, block has two. There are two possibilities. either block will move or it will have tendency to move. So based on these two criteria, frictions are defined. One is static and second is kinetic. So that's it for now. Okay, thank you so much.